What exactly is a brushed motor and what is a brushless motor? A video to understand. Have you ever realized that now? But whenever you buy an electrical appliance with a motor, you will talk about whether the motor is brushed or brushless. So what is the difference between them? To understand this, we first need to know how the motor to realize the rotation. When we went to school, we learned that if the wire is wrapped around the cord to become multiple coils, when the wire is energized, it becomes an electromagnet. It has the same polarity as a permanent magnet, following the same principle of repulsion of the same pole and attraction of opposite poles, and its polarity can be changed according to the direction of the switching current. So if we put this electromagnet on a shaft and place a permanent magnet on each side, when the electricity is energized, the electromagnet will rotate because of the force brought by the polarity. If we change the polarity by constantly changing the direction of the current, the electromagnet will keep rotating. At this point, we replace the permanent magnets on both sides with stronger bent magnets. The electromagnet is simplified by replacing it with a coil of wire. And when we energize this coil, current flows through the coil, and a magnetic field is present, so the coil is magnetized and starts to rotate. But the problem comes when the coil gets halfway through the rotation and turns so that it is opposite the polarity of one pole of the permanent magnets. Then it stops and won't rotate anymore. Again, we can keep it spinning by changing the polarity by changing the direction of the current as before. But it is obviously not practical to change the direction of the current by constantly switching wires in this way. So engineers invented an ingenious device, namely a steering device and carbon brushes. The commutator resembles a ring, using a small gap to split the carbon brushes, which in turn use a spring and the commutator in close contact to conduct the current. You can think of the commutator as a current shifter that automatically switches the direction of the current whenever the motor is turned at a particular angle, thus flipping the coil's magnetic field once so that the direction of the force is always the same, and the coil can rotate round and round and round and round. In order to make the rotation smoother, we can add more armature winding coils and divide the converter's ring into more parts as well, thus making the motor more efficient, which is called a brushed motor. Brushed motor design is particularly classic, simple and practical, but it also has natural disadvantages. Because the carbon brushes and the steering constantly friction, the brushes are very easy to wear. The contact surface is also prone to sparking. There will be arcs, noise, low efficiency, short life. So then there is a brushless motor. The principle of brushless motor is actually very good to understand. It is the structure and brush motor reversed, the fixed part of the coil into the winding, and the rotating part replaced by permanent magnets. The coil does not move, so naturally there is no need for brushes. Instead, the current is steered by an electronic controller, which takes into account the real-time position of the rotor, and then precisely feeds different coils to create a rotating magnetic field so that the magnetism pushes the rotor to rotate. Without brushes, there is no friction, resulting in a longer-lasting motor with higher efficiency and more flexible speed control. However, brushless motors require more sophisticated electronic controllers, sensors, and algorithms to precisely control the direction of the current in real time, which is not only costly in terms of hardware, but also much more difficult to develop and debug. That's why you'll find that buying appliances with brushless motors is usually more expensive than those with brushed motors. Okay, does this make sense to you now?